we are looking at work as a path function and the implication of work being a path function. So let's look at what is path function though. So if you guys remember this discussion, you have your place, you have your school. So you can reach your school straight up, or you can go to your friend's place and go to the school. So in each of this case, the distance that you travel and the calorie that you burn are different. So say these two are said to be path function. They are path function. Why? Because it depends on the path you move from your starting point to the ending point. Here we are discussing that work is a path function, and mainly we are looking at the implication of this, right? So let me start off by talking about work being a path function. So this is a pressure volume graph. You have a starting point, we have your ending point, and you have your one path, you have your say second path. So this two path, the change in internal energy is same for both the paths, but the work 1 is not same as work 2. This is path 1 and path 2. Simple reason being, if I figure out the area under this curve and if I figure out the area under this curve, they will be different, is it not? So area under path 1 would be something like this. Let me erase this. This is the area under the path 1, while the area under the path 2 is this. So clearly these two are different. They give different results. They will give different. Yeah, they'll give different work. Do you guys agree? So this is the difference between taking different path and the work done is different. That's it. What is the consequence of this? We'll explain that. So let me just finish this up. So important point to reflect on: work depends on the path. So we have the starting point and the ending point. The ending point is the same for both the case. But area under path 1 and area under path 2 are not the same. So work is different. Why? Because work is a process variable, not a state variable, while the internal energy is a state variable. So delta U is same for both. Okay, so that we have understood. Next, we need to understand something called a cyclic process. Cyclic process, the internal energy will be, change in internal energy will be 0. So what is cyclic process? Again, we have your pressure volume graph. So this is your starting point and this is second point per se. Let me put it as a diamond. So you can start in this manner, go to this point and then come back to this point again. So this is a cyclic process. Can you tell why? It's quite simple, right? Because your starting and ending point is the same. So you start and end at same point. And so you have this to be a cyclic process. Okay, so that's your cyclic process. Work in a cyclic process is the area enclosed by the loop. Okay, now the question is, what is the work done over here? Because here we spoke of area under the graph, here also we spoke of area under the graph. But here we are starting from a point and going to the same point. So is the work done 0? It can't be. It is a path function. So if this is a path function, then what do we do over here? How do we calculate work over here? So we divide it into two parts, right? So we divide it in two parts. So the way to go about doing this is, we divide the process. Let me actually put the heading first. How to calculate work in cyclic process. So basically we divide this into two parts. One is this, or let me change the color. Say one is this and the second is its neighbor. Okay. So this is first part of the graph. This is the first part of the graph. And this is the second part of the graph, for example. First part of the graph, we are seeing this. And second part of the graph, we are seeing this. So what do is, we figure out the area under the graph, as simple as that. Here too, we figure out the area under the graph. So, okay, so we are dividing in two parts and we are figuring out the area under the graph. Now, once we figure out the area under the graph, what do? We subtract. Okay. So what do we subtract? I mean, obviously we will subtract this to area 1 and area 2. So work over here will be, this is positive and this is negative. Area 1 plus minus of area 2. Okay, but this is very important for us to understand. Why is this positive and why is this negative? See, first thing, we are moving in process 1 in path 1. For example, if I call this as path 1 and this is path 2. In path 1, volume is increasing. So this is work is done. Work is done by the system. Here work is done on the system. V2, V1. This is work done on the system. So remember, work done by the system is positive. We have to go back to our sign convention. So this comes out from our sign convention. It's not because that we have path 1 and path 2. It is not because of that. This being path 1, it has to be positive. This being path 2, it has to be negative. It's not that. It's because of the direction. The positive and the negative, it originates from the sign convention, which is basically, we're talking about the direction of the work. Work by the system is positive and work on the system is negative. And why is this positive? Why is this negative? We have exclusively discussed all of this, but this has to be very clear. We are looking at expansion over here, right? So this is expansion and this is contraction or getting smaller. Okay, guys. So let me take this entire thing the other way around. Just a second. Okay, let me do this again. So we have the same starting point, same intermediary step, but the path which I take is this. So this is your path 1. I think I'm going different, right? Yeah. Can you see that? My path 1 is different. And my path 2 is different. So here my path 1 is this. And here my path 2 is this. But here too, this formula holds good. Here too, it's the same thing. So in this case, this is my area 1, this region, and this is my area 2. I have a quick question for you guys. In which case, so if this is case 2, this is a cyclic process 2. So your starting and the ending point is the same, but this is case 2. So this is a case of anti-clockwise. This is a case anti-clockwise. Anti-clock. That is a case of clockwise. Case of Clockwise. Now, what my question question to you guys is, in which case the system will gain energy? So this is area 1. This is area 2. Area 1 and this is area 2. So here too you can see that this is work done by the system. So this is positive and here the work is negative. Okay. So we are going to compare work. I'll call this as clockwise. So C and this is AC. In both the cases, the formula is same. My question to you guys is, in which case is the work mode? WC versus WAC. So, or let me put it this way, in which case the work is positive? Clearly, WC is greater than WAC. Right? WAC is a negative. This will result in a negative value. This will result in a positive value. Right? Because area 1 is bigger than area 2. So this is positive and this is negative. So this is a positive value and this is a negative value. So your system will lose energy over here than over here. So it will lose more energy over here than over here. So that's one thing that you can tell. Of course, there are other dependent variables also, but this is the general conclusion from this, connected to this. Okay. So basically my question is, in which case, because of the work, right? This is purely because of the work. In anti-clockwise, it will lose, actually it will gain energy. Honestly, this will gain energy over here because of the work. And here it will lose energy because of the work. Okay, guys. So again, it's a very simple process, very simple thing. It's like we can teach this to a 6th grader also, right? Now, cyclic process, work in a cyclic process is the area enclosed by the loop. So basically, technically, if I subtract this two, what will I get? This region is what I'll get. So this is the work done. And here too, this is the region that I'll get. And this is the work done. So area enclosed between the paths is the work done. So there are two possibilities, clockwise and anti-clockwise. So in clockwise, expansion on upper path, right? In clockwise, my diagram is better actually. Expansion is in the upper path and contraction is in the lower path. So compression on the lower path. The enclosed area is positive. So you can see this region is positive. The net work done by the system. So heat, this is an example of heat engine. So we are losing heat per se. When it comes to anti-clockwise, the opposite is true. So here the compression is upper part. That's why the green is bigger. While the expansion is the lower part. So this is the red part. So you can see there is a color change. This is bit green, reddish. Here it is reddish. Here is purely red. Here it is purely green. So net work is done on the system. This is an example of refrigerator and heat pump. I won't go to the detail why is this heat engine and why is this a refrigerator example. So I'll just let it be for now. So last part, I know it's a pretty big video, but this is something that we will be learning in detail. So we'll just get exposed to it. So we have different processes. We have learned the names: isochronic, isobaric, isothermal, and adiabatic. So we know that in adiabatic, we have no exchange of heat. Thermal, same temperature remains same. Isobaric, pressure remains constant. Isochronic, volume remains constant. So graphically, how does it look like? In all of these cases, we are looking at pressure volume graph. So you can take a pause, have a look at the graphs and try to relate it to whatever the names it is associated with. Just have a look. Okay, so you don't have to understand a lot over here, but just have a bit of common sense. For example, isochronic, volume is constant. That's why this is a vertical line. Isobaric, pressure is constant, so it's a horizontal line. Isothermal, it's a curved line like this. Adiabatic, it's also a curved line, but it's below the isothermal. Why? I can't explain it now because it will be a very lengthy video. So, but this is so. And finally, what do we have? The summary. Okay, so that you guys can have a look. So let me go back to my explanation. Yeah, please start. So this is to do with recalling of path function. Recall the idea of path function. And now I think this is good enough. No, I think I should show you guys this as well. And then this summary. So all of this, basically everything and anything over here will be discussed in detail, and this too. Okay, so this is just a glimpse of what we're going to learn. I'm trying to hint towards what we're going to learn so that you start thinking about it. So when I actually teach, you have some basic idea and it's easier for you to learn.